Next up, we have Heather Fotherby from NRSI, which is Natural Resource Solutions, Inc. Only saying that once today.
Thank you. Yeah, I'd just like to point out that I reused this slide, and that isn't a northern Myotis. But yeah, thanks for the introduction, Pauline. I have some interesting findings regarding northern Myotis maternity habitats to share with you today. As Eric mentioned yesterday and Alex this morning, maternity roost sites are temporary associations of reproductive females where they can give birth to, nurse, and wean their pups. And so they're really, really important they play a crucial role in the reproductive success and population dynamics of a species. And their identification and protection is of the utmost importance for the conservation of bats, especially our rare bats in Ontario. So that's the focus of my presentation today. And for the last couple of years, before I jump into that, our knowledge of maternity sites in Ontario is generally lacking. For example, prior to this study, we were only aware of 2 maternity sites for northern Myotis in Ontario, one in a building and one in a tree roost network that Toby alluded to yesterday. So we set out to contribute to the conservation of our endangered tree roosting species, including northern Myotis, little brown Myotis, and tricolored bat, by improving our understanding of the presence, distribution, and structural characteristics of maternity habitat with a focus on natural roost sites. So we developed 3 main objectives for our study. The first one was to evaluate the presence and distribution of our 3 target species in southwestern Ontario through capture surveys. Our second objective was to evaluate the presence and distribution of our 3 target species, their natural maternity roost sites, through telemetry surveys. And our third one was to quantify maternity roost sites, their characteristics of any confirmed roost sites. So to meet our first objective, we conducted 53 nights of mist-net capture surveys across 21 study sites in 2022 and 2023. In 2022, we focused our surveys on 4 main sites, but due to a lack of captures of our target species, we revised our approach in 2023 by increasing the number of study sites in order to expand our search area for our target species. To meet our second objective, we attached radio transmitters to any captured juvenile or reproductive females. And then after releasing them, we tracked them during the daytime to investigate their roost selection. To meet our third objective, we were not only interested in quantifying any used habitats, but in answering the question, do bats select maternity roosting habitat non-randomly? So are they selecting specific habitat characteristics or features, or are they just using what's available to them? And to answer that question, we collected 12 structural variables at confirmed roost sites, such as the diameter at breast height of any confirmed tree roosts, the canopy height within the vicinity of that confirmed tree roost, the distance to the forest edge, and 9 other structural variables that we'll get into a bit later. We documented those at used habitats and at randomly selected or available habitats. And for every used habitat, we randomly selected 1 available habitat. We were also interested in asking the question, is the current provincial protocol effective at identifying potential natural roosting habitat? As I mentioned earlier, it's really important to protect these types of roost habitats. And in order to protect them, we need to be able to identify them. So is the protocol that we're using effective at identifying those habitats? And to do that, we applied the protocol to any vegetation communities within which we confirmed natural roost sites. So over all of our study sites and across both of our monitoring years, we captured a total of 217 bats. Of those, the majority were big brown bat. So maybe that's why I put a big brown on the first slide. We also captured 5 other species. We had small-footed, red bat, silver-haired, little brown Myotis, and northern Myotis. 56 of those captures, or 26% of them, were species at risk, and only 10% of them were our target species, consisting of little brown Myotis and northern Myotis. Of the little brown Myotis that met our requirements for tagging them, we were able to confirm 2 building roosts, which were not the focus of our study, so I'm not going to talk about these any further. But Alex, I thought I would mention the one little brown that we captured. She traveled 5 kilometers to her roost site. There you are. Yeah. So we thought that was interesting too. But we also captured 1 northern Myotis in 2022 and 1 in 2023. And by tracking those 2 individuals, we were able to confirm 7 natural roost sites. So these 2 individuals, they were captured at the same site and within about 50 meters of the same capture site. In 2022, the individual that we tracked retained her tag for 4 nights before she dropped it, and the individual in 2023 retained her tag for only 3 nights before she dropped it. They were roosting between about 110 and 600 meters from where they were captured, and the distance that they traveled between their roost sites ranged from 5 to 350 meters. We calculated the roost area that they were using. In 2022, they used the first individual, her roost area was 1.8 hectares, and the individual that we tracked in 2023, her roost area was 0.1 hectares, but keeping in mind that we only tracked them for a few days. Given this is only the 2nd known natural maternity roost site in Ontario, I thought you might be interested in seeing some of the photos of the confirmed roost trees. This is the first roost that we tracked, the bat that we were tracking in 2022 to. It was a sugar maple snag, and it was 35 centimeters in diameter at breast height, and she was roosting 1.6 meters above ground. This roost actually fell over between 2022 and 2023. The second roost that we tracked her to was in American Beach. This tree was 16 centimeters in DBH, and she was roosting at 1.5 meters above ground level. The third one is the one I find the most interesting. It was only a 6 centimeter diameter at breast height, American Beach, and she was only roosting 0.46 meters above ground level. The last one that we tracked her to was a white ash snag. It was 46 centimeters in DBH, and she was roosting at approximately 13.5 meters, which was determined with the use of a clinometer. In 2023, the first roost that we tracked the female to was in American Beach. It was 28 centimeters DBH, and she was roosting at a height of approximately 11.9 meters. The second roost that she used was again in American Beach, only within 5 meters of the first roost that she was using. It was 23 centimeters in DBH, and she was roosting at a height of about 9.6 meters. And the last one that we tracked her to was quite similar to the last roost that we tracked the 2022 female to. A white ash snag, a larger tree at 62 centimeters DBH, and she was roosting at about 20.8 meters above ground level. So were the bats that we tracked, were they using habitats, or were they selecting their maternity habitats non-randomly? When we compared the variables that we collected at the confirmed roosts to available trees, we didn't find any significant differences. This might suggest that they're not selecting specific habitat characteristics or features and are just using what's available. But we do recognize that this is a very small sample size and very few, and it would be great if there were more studies maybe at Toby's site. And this table here is a summary of the means plus or minus the standard error of some of the variables that we collected at the confirmed roost trees. And although they're all really interesting, I do find it most interesting that the mean height of the roost tree was lower than the mean height of the tree canopy within its vicinity. This suggests that they're not using the tallest trees available and not necessarily those with the highest sun exposure. And what about the current provincial protocol? Did it correctly identify our confirmed maternity habitat as natural roosting habitat? I don't have the time to get into the depths of the protocol, but basically the plot-based approach consists of randomly selecting plots in the vegetation community that you're assessing for bat habitat. And within each of those plots, you're counting the number of potential roost trees. And with that number, you can calculate the roost tree density for that vegetation community. And the vegetation communities that have a roost tree density of equal to or greater than 10 roost trees per hectare are considered high-quality roosting habitat for bats. So when we applied that to the vegetation community within which we confirmed northern Myotis to be roosting, we calculated the roost tree density to be 34.86 roost trees per hectare. And I do realize we did this after we recognized the fact that they were using really small DBH trees. So of course we were counting all the small trees where we were finding roost features. And I know others only count those that are greater or equal to 25 centimeter DBH. So the number of roost trees, the density with regards to greater than 25 centimeter DBH also met the criteria for being identified as potential roosting habitat. So with regards to roost density, yes, the protocol was correct in identifying it as potential roosting habitat. We took that a step further and applied the protocol to the confirmed roost trees as well. And the roost tree density was even higher when we were only considering the habitat within the vicinity of the roost trees. It was at 86.67 roost trees per hectare. Another recommendation in the protocol is that the best candidate roost trees are within the highest density of snags or in a cluster of snags. And when we looked at the number of potential roost trees within those plots that we centered on the confirmed roost trees in comparison to the available plots that we did as per the protocol, we did find a significant difference in the number of potential roost trees. There was a higher number of roost trees in the plots that were centered on the confirmed roost trees. And I apologize for this table. It's a lot of information, but it basically summarizes a lot of the criteria that is outlined in the protocol and whether or not our confirmed maternity habitat met that criteria. For the most part, it did, but there were a few differences. For example, the roost tree height, they recommend the best candidate roost trees to be in the tallest trees. But we, as I mentioned earlier, the mean tree height for the confirmed roost trees tended to be lower, or was lower than the mean height of the tree canopy within the vicinity of those trees. So not always the tallest tree. And we found the majority of the confirmed roosts were American beech, which is a tree species that isn't even listed in the protocol as likely having a roost feature. And they also recommend the best candidate roost trees are those that are high in a tree. And as I mentioned, we found at least 2 confirmed roost trees that were less than 10, or they were smaller. And I'm getting off track here, but in terms of the height, we found 2 roost trees where they were roosting less than 2 meters above ground. So, in summary, yay, we've contributed to our knowledge on maternity habitats in Ontario by identifying the second known natural maternity roost site for the species. And with regards to our ability to be able to identify additional maternity habitats, the current protocol did correctly identify ours as natural roosting habitat with regards to roost tree density. Our study also noted that northern Myotis prefer to roost in locations with a higher number of nearby potential roost trees. This is consistent with other studies and could be related to their roost switching behavior. The lack of significant results that we found in our study could suggest that northern Myotis have some flexibility in terms of their roost selection. Not always the largest tree, not always roosting at the tallest possible position in the tree. For example, we confirmed northern Myotis maternity habitat in trees that were less than 10 centimeter DBH, and they were roosting as low as 0.46 meters above ground. And there was variability in terms of the height that they were roosting at. And with that, I'd just like to give a big thanks to everyone that made this study possible. There's a huge list of names, and they're not all on there, but thank you very much.
Thank you, Heather. Now on to questions.
Thanks, Heather. That's great work. So regarding the protocols, they tend to be pretty generic of bats do this. So based on what you've learned, do you think it might be worthwhile to look at a species-specific approach, that northerns might be doing something different than little browns and things like that?
Yeah, that's it's possible that we could do that. But at this point, our sample size was just so tiny. And I feel like we don't know enough about what the other species are using yet either. I mean, it would make sense to split them up because I'm sure they're using slightly different habitats, but we don't know that for sure.
Hey, you mentioned that you found a lot in beech trees that weren't even listed as being likely to have potential roost habitat in them. What was the state of the beech trees you were seeing? Could it have anything to do with changes in the tree's appearance based on beech bark disease or anything like that?
Yeah, that's a good question. There have been other studies that have noted that they don't necessarily select a specific species. They'll select what's available in terms of the roost feature. So the habitat that we tracked them within, there was just a high proportion of beech available, and so probably more of a chance that a beech would have a roost feature that they would like. I don't know if that answers your question, but.
You're using the term maternity roost. Do you actually have evidence there were pups in each of these roosts? I mean, was this just where an individual during the breeding season was roosting, or were these true maternity roosts in the sense that there were one or more females with pups?
Right. So we have no confirmation that there were pups. We did do exit surveys in 2022. And we had volunteers at each of the confirmed roost trees. But that was I forget how many days after we finished tracking, unfortunately, and we didn't have any bats exiting. So it was a reproductive female that we were tracking, which is why we're referring to it as a maternity roost, and we know they don't always roost in high numbers. So maybe not the correct term, I guess, but we're making assumptions.
This is actually going to be our last question for Heather, but if you have any more, feel free to track her down during the break.
Thank you.
Oh,
One more.
sorry.
Sorry.
I was just curious, because you looked at a lot of the roost switching behavior, and we're talking about trees here. So maybe it's not a species specific for the tree type that they're roosting in, but did you know, or do you like pick up on any, just like anecdotally here, any of the climate variables and compared to where they were roosting in terms of height and DBH?
Yeah, we didn't look at temperature data. Is that what you're getting at?
Like, what if it was like hot that day, you know? Like, were they roosting lower and thinner trees so that they would have, or the opposite, some more insulation?
Yeah, that's a really good question, and no, we didn't document that. It was the end of June, early July. It was warm out, but I don't have any actual numbers for you. Yeah.
Thank you, Heather.